Hi everyone. So we have microphones, and if you want this to be recorded, you need to speak to the microphone. So there's one here, one there. So I don't want to do a presentation. I don't have slides or anything. The question here is what? So we've been having like multiple conversations, and I just want to sync up with the priorities that we may start doing in the future, and also things that we could be doing now that are different than we're actually doing. So there's not a status update, things that we've done, etc. It's just asking the room what the technologies that we should be looking into that we're not yet. So I'm going to give a quick list of examples of things that we can talk about, and then you can say this is important, this is not, and then whatever is important we discuss. So in the list that we put up before, one of the things is SPAC and RPM integration. SPAC is a software repository of source codes rather than binary packages. And you use this because the RPMs or the dev packages, they're built for the minimum architecture, so they're not optimized in any way. And so if you have a math library or go for it. If you have a library that you care about, that you want to compile specific for your chip, you need to recompile everything. And that's what SPAC does. You say install this library and compile with these flags, and then SPAC would then build all of the dependencies and then build your package. So you don't need all of your packages built to your specific hardware. You just need the ones that are going to be running your HPC kernels rather than administrative tasks. So this is one thing. Are people interested doing something similar? How are you guys controlling how you build the libraries? Are you building everything by hand and then distributing this into the cluster? So this is one of the topics, and then of course now that you have optimized libraries, you would use that for benchmarking and for running the. So if we are using something like SPAC, we want to be running our benchmarks with the SPAC packages, and that kind of ties up into contributing back to the SPAC repository, compiler options and source code and libraries and dependencies that we might need for our own builds. The other topic is MPI and RDMA. So right now we're just running the standard MPI packages tests that we have in the Open HPC, but we're just doing this over whatever network we set up. So because it's an easy one, I just picked Open MPI running through either 10 gigabit or 1 gigabit, and we're not doing any kind of RDMA testing or anything, but we do have RDMA enable the network cards. So the question is, what kind of MPI do we care about? I was looking at on ARM, Open MPI is better, scales better than MPitch. So this is one of the reasons why we picked Open MPI. But I don't know, maybe some customers of the members have workloads that depend on a specific package or something. So what kind of packages do you care about related to MPI and RDMA? So that's the second topic. Third one is about Ansible. So we have a talk tomorrow about deploying OpenHPC with Ansible. Is this something that people are doing, something that people care about, and how we can get all of the members to test the work that we're doing, plus the upstream changes. So I'm going to stop here. Which topics would it be? Can anyone raise a hand and say, I want to talk about this, I want to talk about that, I don't care about MPI, or I doubt you don't, but anyone?
Maybe you could talk with
Yes, can you?
No. I want to give some opinion with the NPI.
Oh, okay. So the MPI tests we did in our local lab weren't very extensive because we didn't have a lot of machines. But this was a test done in the ARM HPC user group. And they tested OpenMPI over Ethernet and over InfiniBand, and MPitch over them too as well. And OpenMPI over Ethernet scales better and is faster than anything over OpenMPI over InfiniBand. No, OpenMPI over Ethernet scales better than MPitch over InfiniBand. So MPitch is, according to the, I think it was a 14 node cluster, ThunderX. That was, MPitch was slower regardless of InfiniBand or Ethernet or anything. And OpenMPI was like clearly better than in the scalability and performance. So that's why all the tests, all of the environments that I'm setting up on the test suite and everything, it's all OpenMPI across. We still don't have InfiniBand switch, but we do have network cards that support InfiniBand. So we just need somebody to kindly donate a switch.
What do you need for a switch? How many ports? 48?
48 would be amazing, but no, we don't need that many. If we have like 3 clusters of 5 machines, there will be like 15. So
20, let's say
24 will be, yeah.
Okay. Any other specific requirements outside of that?
So this is another thing that I was thinking of. So when I did the requirements for the 10 gigabit, I was thinking about using one of the 10 gigabit ports for the file system, for the Lustre file system. So we have the server in a machine,
Right.
and then we use a specific network VLAN for the file system, and another specific VLAN for the MPI, and another specific 1 gigabit VLAN for like internet and administration.
Okay.
Right. So this means that all of the machines will be connected 3 times. So we need 3 times more ports. Now, if the file system is over 10 gigabit and MPI is over InfiniBand and administration is over 1 gigabit, then now you only need like the 3 switches anyway that you would have, and it will be 15 ports in each switch.
Okay.
So I don't want to scale like a lot of, use the same switch, or we can, if we have different switches, then we can use them. We don't need a specific requirement, unless, of course, a member has, or somebody in the SIG has any specific requirements. We're just going to use that topology. Does that answer your concerns? Okay. Maybe. A lot.
I think most of it, I think. And another thing, I wanted the Lustre. I want your opinion of the Lustre. What
Right.
kind of work, and what's your opinion about maybe we can use the Lustre in HPC?
Yeah.
And if we want to deploy this, in your opinion, how long will it take to make it to provide to our customer, Lustre?
I see. So as soon as we set up the lab, we're building up the machines now, and as soon as we set up the lab, we will run the Lustre server into the admin node and the Lustre clients into the the ARM machines, right? And according to the SIG meeting at the beginning of the week, the Lustre client already works on ARM and has been tested by other members. So it shouldn't be a big issue. No, it shouldn't. It shouldn't be a big thing. If you have some software that you have tested, or if it's just like a speed test, or just a dummy file transfer kind of thing, we can do this. But if there was an application that actually makes heavy use of distributed file systems, then it would be interesting to run that in the clusters and see if we can find any performance differences between different vendors and maybe even compare to Intel machines. Go on to it. Yeah.
What is a high-level objective of this working group, and how will those tasks help on those objectives?
You mean the HPC-SIG?
Yeah, HPC-SIG, and especially how does this task can help to achieve those, make progress toward those objectives?
Right. So the HPC-SIG is a group of members and engineers. They're trying to just build HPC clusters and solve the upstream problems that are holding ARM back in the HPC arena. So compilers, packages, libraries, file systems, networking, firmware, kernel, all of these issues. So how do we prioritize this? Well, first, the members tells us what's important for them and what's not working, what it is working. But also there is a strong component of CI that not only we want to fix problems, but we want to make sure that they don't come back. So that's why we're building a lab that will be testing in different vendors, different configurations, different tests in the matrix to say, okay, we've run all of the tests on all of the configurations and everything's great. So then every time we have a new release of OpenHPC, which is this repository of HPC setup, management, and packages, that it's still working on all of the configurations that we care about. And the things we care about are the things that the members tells us that we care about, plus the open source things that we need to care about to make sure that those things are completed.
If I understand correctly, is make sure that the open HPC will run in all configurations. But how does the spec versus RPM help to achieve that objective?
Because RPMs are built for the base architecture. So it's like CPU equals minimum possible. So it doesn't perform well anywhere. Now, if this is a management package, like Nagios or, I don't know, Ganglia or some monitoring tool, or then it doesn't matter. But if it's a library that you use like BLAS or FFTW, something that you're actually going to use in the application, then it matters a lot. And so, for instance, if you have like ifdef saying, if you have SVE, if you have Neon, use this path of the code, which is like intrinsics, then you want to compile with a flag that enables SVE, right? So the RPM packages will not have that. So everything will be plain code, no vectorization, no anything. And SPAC is just a source. So what you say is install this package, and then the minimum it does is already better because it says CPU equals native. So if the compiler can detect that the core that you're running has SVE, you don't need to add anything else. You just say build this package and you get a much better performance. But you can also pass compiler options specific for the packages. So if you have two different libraries and they have the same dependency, but you use different compiler flags, SPAC will actually recompile the dependencies and keep them binary in the local file system so that library A uses the flag A, library B uses the copy of the library with the flag B, and so on. So it keeps all of those things intact. So instead of you having to do this, because normally what happens is the user A will go there and build the whole tree. And user B will go there and build a whole tree. And then user A wants to use the B library and he can't. You have to compile again into a second copy of the exact same thing. So SPAC will do this in the system level. So it's the same thing in module load. You know, when you have like a cluster with like different versions, ARM has something similar that it loads. Like you say, oh, give me this module, and it just picks up the right thing and puts it in the path, and now you have this. So module load does that. And SPAC can work with the module load. So when you build the dependencies, you say just module load GCC 7 OpenMPI, and it gets all the environment for you. So when you do GCC.c file, it just does exactly what you want. Okay. And then when you compile spec, it's going to use the right GCC, the right libraries, everything fine, and then you run the benchmark. You don't need to pass magic flags or something to the job. It's a configuration management, not a compilation management.
Okay, that makes sense. Thanks.
Jackie, you asked a question about Lustre, and was that specifically for having Lustre apply to OpenHPC? Is that your question, or you would like to see Lustre working on OpenHPC? Yeah. So currently the TAC servers have Lustre 7 installed for Intel, but currently not on ARM. So one of the directives that we've taken as part of the HPC-SIG, along with the members earlier this week, was that we will run some initial analysis by running a Lustre client and identifying some of the issues and areas that we can make influences there to ensure that it works well on ARM. So that's some analysis that we have undertaken to do, and once we have run the client, this will define a set of work and activities that we can prioritize to ensure that Lustre works.
I don't know HPC, but I have a question on networking part of it.
Okay.
So I'm from the networking background, and there's a lot of networking acceleration done using DPDK and user-space networking. So is there any use of that in HPC?
We haven't looked at all at this. We do have the BDK folks in the enterprise group.
Yep.
But I don't know what's the status of that. Do you wanna?
All right. So part of what Renato, part of what the HPC-SIG team is going to do is actually do a lot of the testing and benchmarking on the reference platform kernel. We have to do that right now because all the distros don't actually work properly. And in that context, part of the other part is that they inherit a whole bunch of the technologies that are being developed inside or used inside of the enterprise group. So one of it is DPDK. And so I suspect that that will come into play down the road, but this is early days. I mean, we're just getting the servers racked and stacked and some of the performance testing done. But that's part of what the enterprise group does over what LNG does is we do all the QA, CI test. And so that will tie into that work that he does.
So does, I believe we talked about MPI, and I kind of got a feeling that that's the networking part in HPC.
Yeah.
Is that accelerated using DPDK today?
Not today.
No.
Okay. Okay.
But I mean, we can look at that.
Yeah, I mean, I was wondering if there is a use case for DPDK in HPC, for example.
We're not ruling it out just yet. We do understand that moving data is costly, but right now our current priorities is we want to ensure that ARM HPC is in par with Intel, with the SVE architecture that's instruction set that's come out, and with hardware in the pipeline, we need to ensure that we are fully ready that for core we are equivalent to Intel at the moment. Then we can ensure that we've got a good offering and a good standing in the HPC space. But whether it's out of scope, no, but we're just not there yet.
Okay.
Also, the thing with MPI is that MPI has a lot of libraries to understand what is the fastest pipeline that you can use, and how you use it, and etc. So I don't know how DPDK would work with MPI in that sense. Maybe like stepping on each other's toes kind of thing. So, but this is the kind of thing that we can look at and see, and this is future.
Yeah, I think the point is DPDK is one of the tools that can be used. It's just way too soon for.
Okay.
Yeah.
Okay.
The other thing as well is we have the QMU guys in the room, so just throw in the ball, and Alex and Richard. So they're working on the SVE QMU emulation. Yeah.
Actually, do you want to say a few words about what you've done and how I can help application development?
Yeah, I mean, there's going to be a talk tomorrow where we talk about the upstreaming process, but we're pretty much 99% complete on a Linux user implementation of SVE. So the only thing that we've not implemented yet is the find first fault register. That's mainly because we didn't have any applications that used it. So, but there is a branch available, so if people want to actually start compiling stuff for SVE and testing that it's running, it's ready to go. We expect it to be fully upstreamed in QEMU, not in this release, which is currently rolling, but in 2.13, which will probably be around about August, hopefully well before any hardware is actually available.
So when you say 99%, is this in the number of instructions?
Yeah, well, yeah. So basically, all the instructions that don't involve the first fault register, that aren't system-specific instructions.
So if I have an ARC64 machine without SVE and I want to emulate SVE application, can I use the rest of the instructions?
Not with QEMU, so it will translate all the ARC64 instructions into ARC64 instructions, so there'll be a penalty if you pay for that. It's not like it won't just trap instructions that it doesn't know what to do with. So it's good for testing, but don't expect performance.
But it's the only open source. Sorry. But I think the thing is, the reason why we're doing this is because this is the only open source model for SVE today. I mean, there's not even silicon for it yet.
Yeah.
Exactly. There's no silicon, but we can't just wait for the silicon to land. We have to ensure that the application developers are ready to get the application started.
Yeah. And it will certainly be faster than doing it on the fast model.
And it'll certainly, and faster than not doing it at all. Any other questions for Alex? But I can go to Git and I can pull it.
Yeah, I've got the branch on my slides. But yeah, come to me if you want to pull it today and you can't wait till tomorrow.
When's your session tomorrow? What time?
Tomorrow afternoon at
2
something like that.
It's 2 o'clock.
I can't remember.
In one of the ballrooms.
It's at this point that people suffering jet lag just completely zonk out their brain. So
Yeah, 2 p.m. SVE and QEMU, and it's in, it doesn't actually say it on the thing, anyway. But yeah, 2 p.m.
Cool.
I still have a question about SVE for QEMU. And do you have a roadmap to release the SVE for QEMU version? Maybe in the next half years.
Yeah, we've got all the prerequisite work into the current release, which is rolling, which is 2.12, which is currently rolling and will be out in the next month. So full SVE support will be in the next release, which will be around about August, I think.
Okay.
Sorry, when I say full Linux user SVE support, so we haven't implemented the system registers, so you can't do system emulation, but it's enough for compiling user space programs and testing they work.
So do you mean that still there is no critical issues for the SV or something not supported yet features?
So currently we haven't done the first fault register support. So that's one bit that needs doing, but we haven't actually found any programs that use the first fault register yet. So it's mentioned in ARM's examples that they have on their website, but we haven't seen it in any actual real world code.
Okay, because I have another team. They are downloaded the latest version. Maybe they have touch contact with you, and he's Israel, and they said, and now they are waiting for you with this version. When they needed to support their chip to design for the SVE and testing.
Yeah, so the branch is publicly available. It's in Richard's GitHub tree at the moment. The patches are on the list. So the final set of patches is 67 patches to implement all the instructions that we do. And you're more than welcome to come on the mailing list and review them there. But I can give you the branch. I just don't know it off the top of my head. So.
Okay, thank you.
But this release will have all of the background work like FP16 and everything. And the
yes, so because SVE has a whole bunch of prerequisites, including complex number support, half precision was the big chunk. That's all in the release that's currently rolling. Yeah.
So you're gonna. I guess the thing here is just get Tian on, give him the link so we can pass it on.
Yeah.
If you're looking for some SVE model to run, is fast model the answer? Because fast model is ready now.
Yeah. So there's the foundation model and fast model both do SVE emulation. I think the foundation model has a limit on the total vector size, but the fast model will do the full size. The QEMU implementation emulates a full size 2048-bit vector register.
Say the QEMU model will be supporting more features, or I don't get it, because Tian mentioned that seems like you're looking for some emulator that's working nowadays. You are waiting for QEMU to support it, but first model ready, and then first model and foundation model have already supported. Why you have to wait for QEMU eagerly for that? Is it a performance reason or any other reasons that you have to use QEMU?
There are different use cases. There's some reasons why you want to use the model, the ARM provided one. There are other times. So there's a lot of good reasons to use the fast model, right? Absolutely. There are requirements by members of the SIG to have a QEMU-based one, which they will then go and modify themselves depending on what they're doing with their implementation of SVE. And that's the difference, right? So you can't do that with the fast model, unless it just doesn't work. So that's where it's really coming from. It's not to compete with, it's just a different use case.
One advantage QEMU does have is this ability to do Linux user emulation. So it's considerably faster than any system emulation, just because it's not having to model an entire MMU. So for people that just want to test user space programs, that is the fastest solution.
And then there's also additional cost with models as well.
Yeah, I thought they were, well, so certainly you can get them free.
You can get it free now. Yeah.
But I thought that there was some IP issues still.
Well,
you certainly can go to the ARM website and just do a click, download for the foundation model. I don't know about the more full-featured fast model.
For foundation model, you go and download it for free, use it, run with it. The challenge here really is more along the lines of, I need to modify this. I need the open source implementation of it. That's all for some use cases.
And also for open source developers generally, they prefer to have open tools for everything they do.
Yeah.
So.
The other point around that is that in addition to the SVE enablement work that we're doing around QEMU, we're also implementing an SBSA server machine type in QEMU, and the idea is that you're going to link those two together. We have the trusted firmware that we're doing in QEMU as well. So this actually starts to complement itself really, really well. And I've got one of the guys working on the machine, on the SBSA machine in the room. But the whole idea is that this stuff all sort of ties together, which is what the SoC vendors are asking for. So that's why we're doing it.
Any more QEMU questions? So the other topic is about new packages or missing packages between Intel and ARM. There are some, we've done a list, and I think that the two big ones were to do with InfiniBand support, because that was Intel specific, and PAPI, which is the, what was PAPI again?
And current PAPI package status in OpenHPC, as far as I know, that it's lack of optimization for AX64. Some people, I heard some people engage in the optimization for AX64, but it's not included into OpenHPC now. And other thing in the differences about differences between AX64 and Intel machines, MPI or even things, Ember pitch. For example, Ember pitch fully depends on the Intel-specific interconnect called InfiniBus. And so if we use the OpenHPC software stack, we should care to differences between them.
So the other question I have is, we do like upstream validation via running the test suite in different architectures. That's all good, but there's additional tests that we can do in workloads that the members care about, but the upstream doesn't. So this mostly means, because OpenHPC has all of the packages that we can run the tests and it's all good, but there are other things like HPCG that they will not run this upstream. They don't want to run this upstream because it takes too long. So what I want the members to tell me is what packages, additional packages or workloads or benchmarks that you care about that we should be running before the release. Because we want to make sure two things. First, that the new release doesn't break the packages that are not in OpenHPC but are used by the members with OpenHPC. So they cannot break, and the benchmarks shouldn't be slower. So we should track these things at least every release to run a larger subset of the tests, so that if something goes wrong, we can go back to the upstream and say, hold on the release, let's fix this first, and then we push. So if you have something like, I know you care about HPCG, and that is in the list already.
Yeah.
So this is something that we will look at. But if there's like additional things or other members that care about different things, we want to have a list of additional tests that we can do, which make sure that it's more stable and more and doesn't break old stuff. So please let me know if there's additional conditions. Let me know.
I think I discussed HPC with you for maybe 2 times, and 2 times or maybe more. So I focused on the HPC, but I think for open source, if we want to build a HPC solution based on open source software, I think there are a lot of work to do, and maybe the HPC G-SIG member, we can work together, or even ARM, or thinking, we need help from ARM, strong help, or maybe powerful help. We ask for this help, so I want your opinion.
I cannot represent ARM myself, and I'm not from the HPC team within ARM, so cannot answer that question, that request directly. But definitely I will pass that request to the appropriate product manager and the managers. Understand that HPC is critical to ARM, so I see no reason that ARM shouldn't invest enough resource and adjust the roadmap to respond to your request. I think you also have the connection to the HPC group within ARM, Shark, and then I'm looking forward to follow the conversation between your 2 parts. Yeah.
I will contact with ARM team, okay, and I will also contact with the Linaro team, because our customer asked for open source solution, so I must provide this. So we want your help, yes.
They don't want to buy ARM tools. They want open source tools. Right, any more topics, questions?
There are several teams or companies working on ARM, like BSC and GW4 and others, Cray. Can your team share their results?
They don't share the results with us.
Even if they did share their results. Even if they did share the results with us, we can't share it with anybody, right? So, for example, so we can do tests on high silicon, right? We can do tests on Cavium, we can do tests on all of the different platforms, but we will not share that except for, we'll share the results from high silicon to high silicon, and from Qualcomm to Qualcomm, and Cavium to Cavium. But what we will do is we do provide, we take all of those performance metrics of the performance that they have, we equalize that so that you have one band of performance, and then we'll run that against Intel as well. So we'll have measures, but you'll never get the individual performance from different, we'll never provide the different performance numbers for each different SoC. We'd lose all our members.
Yeah.
Everyone would leave.
And our jobs. And
we get sued.
Yes.
Why would
they do a lot of optimize. Can we share the optimize?
So if you think like Cray, they do a lot of optimization and they do improvements in their provisioner and in their solutions. But this is what they sell. So not many of that is open source. So for us, it's not something that we can work on or help or even build on top. So we're doing the open source side of it so that everybody, including Cray, can profit from it. So that is, what Martin was saying is, the performance that we do is ARM. We want ARM in general to be as good as Intel in general, right? And we can do this because we have the different SoCs in the lab. And of course, if there's a big difference between Huawei and some other chip, we're going to tell Huawei, look, there's maybe if we do this, we can work with Huawei in that. But in general, we want the changes that benefit all of the vendors, they have higher priority. So if you have a compiler change that actually makes all of the ARM chips better, this is a better fix than another one that makes just one of the SoCs slightly better. So we have to work with what benefits most of the members, and we can work with individual members separately on what only benefits their own hardware. Make sense? So how long do we have? Another 4 minutes? 15. Wasn't it 15 minutes?
I don't think we need to stay.
No, okay. Yeah. No, yeah, if nobody has...
You're not allowed to leave until you ask 5 more questions.
Yeah, the door's locked. Right, if there are no more questions, then thank you.